So in this video, we're going to talk a little bit about how you can use Octave to analyze vehicle diagnostic data that you get from FORScan. In particular, this is really just meant for like deep dives into diagnostics, so you can look at, say, whether or not your AC clutch is coming on when it should, or if vehicle speed has anything to do with a misfire, anything like that. And I'm just going to show you some of the techniques you can use to do that. The first thing we're going to do here is make sure that we load the I/O package, so that'll enable us to handle the CSV data that FORScan outputs. It'll just make it a lot quicker and easier to get that loaded in and to get it to a workable form. And so the way we're going to do that is through this little command here. So you can see that we're loading in the data from FORScan into a variable called loaded FORScan data using CSV to cell, which is just going to take your CSV and convert it into a cell string array. I believe that's the technical term. I could be wrong. And then this here is the file name of the file that we want to load. In my case, it's a little bit of data from my F-150 that we're going to be working with today. So now down here in our variable editor, you can see that we've loaded in the, oh wow, this is a lot. This was not a good idea. So instead, what I'm going to do here is just do FORScan data header. Now the header in a CSV like this is just that first row that tells you all the names of all the columns, and it's going to be the loaded FORScan data. Oop, not caps lock. Loaded FORScan data, row 1, all columns. Or actually, wait, we should use parentheses here, if I remember correctly, and Control S and F5. And if we did it right, and it looks like we did, we should now get a 1 by 29 cell array that is just the header. So now we can open this up in our variable editor and we can see which column correlates to which value. So you can see here that we recorded time in milliseconds. Misfire, this is just a binary value, whether or not a misfire was detected or not by the OBD. I do not remember what this one does. This was the accelerator pressure mode. If there is no pedal, it'll say no pedal. If there's some pedal, it'll say some pedal. Do first row with header equals loaded FORScan data. And here we're going to type 1:2, colon, and this should work the way I think it does, hopefully. And we're going to give it an F5 and run it. And it looks like it did work exactly the way I wanted. Here we go. So now we're looking at our first sampling of data. So we're going to look at, let's see, time at 0 milliseconds, no misfire. NM has a dash. A lot of these are going to have dashes because the sample rate is actually very quick. So usually the first sample is not going to include any significant data. Okay, so now we need to look at, let's say we want to look at row 200. How can we do that? Well, we can just pass it that we want to look at row 1 and row 200 in a little array like this, and then all columns. And then if we hit F5, it'll run that. We can pop over to our variable editor, or sorry, our workspace, and we're going to see that the first row with header did not change. It's still 2 by 29, which means it only gave us 2 rows, which is exactly what we wanted. And if we go back to the variable editor, now we can see that time has advanced quite a bit. And so now we can actually see some real data. Desired RPM, that's the RPM that the PCM would like the engine to be at. FLI, fuel level indicated 13%. I needed to get some gas. Fuel pressure percentage, 46%. Fuel rail pressure in kilopascals. Anyway, I could go on, but you can see we've got lots of good data, including the actual RPM instead of just the desired RPM. So that's all great. That's all well and good. But what if we wanted to, say, put this data into a graph? How would we do that? Well, first let's look at how we can get, say, just 2 columns of this data side by side, right? So let's say we just want to look at time and RPM. Simple data set equals loaded FORScan data. And here, instead of like earlier how we gave it 2 rows in the row column, we're going to give it 2 values in the column value. So we're going to say all rows of columns 1, and then we can come down here to our variable editor and figure out which which value we want to work with. So in my case, I want the time in milliseconds, so I'm going to do row, and then I want to look at the desired RPM and the actual RPM. So I'm going to need row 1, let's see, row 1, row 7, or sorry, column 1, column 7, and column 17. So we'll come back to our editor. We'll look at column 1, column 7, and column 17. We can see we've got our simple data set is 24,894, just like our complete data. So it's the same length, but only 3 columns wide. So if we want to open that up in our variable editor, we can do so. So here we go. Now we've got the time in milliseconds, our desired RPM, and our actual RPM. So let's just scroll down, say here-ish, and we can see that the PCM was looking for idle RPM, and in fact the RPM was 1,976. Now this doesn't really mean very much, because that just means ideally that the engine won't fall below this, so that if you stop at a red light, the engine doesn't shut off. So it's not like your PCM is calculating what the RPM should be at any given point. But anyway, it's just an example of the data. So now that we've got this, we can start to visualize this kind of data. And the way we're going to do that is by using a plot. So if we just do plot simple data set, let's see if this gives us anything useful. And the answer is, well, it's moving very sluggishly. And now it's not responding. Okay, so not really, right? We can see that we've got 0 to 1 and 0 to 1, and there's nothing here. So, yeah, it didn't really do anything with our data. So we're going to need to specify some additional information. Okay, so we need to back up a little bit here because I made one small mistake. So for processing through this data, we need to do a couple of things first. The first thing we need to do is get rid of the string values so that we can just use a num to string and convert all of the data into numbers that we can then plot. So first thing we're going to do is we're going to go back to our editor here, and we are going to make, we're going to do it with a loop just because it's simpler, 1 to 800, just to speed things up. Simple data set, oops. If strcmp string compare simple data set 1 comma j, and then the string we want to compare it to, which is just a dash. If it's just a dash, then we're going to set simple data set of 1 comma j to 0. Okay? And this will not work because I got these backwards. Or this should be 2 actually. Great, so okay, we ran that, and now if we come back over to our variable editor, we can see we used to have these same dashes here, and now we've just got zeros. So now let's scroll down a little bit and make sure that it didn't destroy any of the other data. No, I'm reasonably certain it didn't. This was the engine at start time, so it ramped up pretty high. Okay, so that looks good. It looks like we successfully removed the dashes from our data for the second column. Format, indent section rigidly, there we go. For I equals 1, 2, 3, since we know it has 3 rows, and then end for. And then here, since we have this I value now, we're just going to replace 3 with I as we loop through. And now if we run this, and I'll switch over to the variable editor while we run it so we can see if it works. And there we go. Now we can see that we got what we wanted. So we got zeros everywhere here. We have no more dashes in the numbers. What we're going to do next is we're going to remove that top row just because that's header data. We don't need that for what we're doing. We know what the rows are. or it's actually measured RPM, not necessarily actual RPM, because I believe it comes off the crankshaft position sensor, so it could be different. But anyway, row 3 is going to be our measured RPM. And again, I did it again, but these should be columns. Okay, so columns 1, 2, and 3, that's what they are. So now we're going to remove that header data. So the way we can do that is with just a simple assignment. We can say simple data set, and we're going to do comma 2, comma 3. Cool. So now if we pop back to the variable editor while we run this, and we do the old gear button, we will get a syntax error because I did not do this right. All right, so now here you can see what we're going to do is we're going to take the first 3 cells at the top, the header data, and we're just going to set them to empty to remove that row so we don't have to think about it for when we go back and process the information later. So we're going to run this. And it ran successfully. So now we have in our variable editor, you can see that this is a 0 by 0 double. So because this is a cell array, it just sets them to empty. It doesn't delete them. But for our purposes, this is okay. And now we can come back to our editor. So I really want to do a quick experiment just with the data that we can see in our workspace. And we're going to do that in the command window so we can actually see live kind of what's going on. So command window here, we are going to look at what happens. First, let's clear the command window. And now we're going to look at, if we do a cell to, and we can hit tab to see what our options are. Let's do cell to mat. That means cell to matrix of the simple data set. Home, and we're going to store this in a variable called simple matrix. And we're going to put a semicolon at the end because this is a lot of information. We don't want this outputted to the console. Okay, so it did that. It's happy with that. And now we can come back to our workspace and we can open up the simple matrix in our variable editor. And now we have almost exactly what we want. So here we can see that simple matrix, if we go back to the workspace, sorry, simple matrix is a double matrix, or is a matrix of double values that is the same size as our cell matrix from earlier. Now what this means is that because these values are in fact numbers and not strings of numbers, now we can start to do things with them. So now we have our program written, we can see what our data is doing, we can look at the commands we're running, and we can see the actual data as it changes. Now what I'm going to do is once again just run a simple plot of our simple matrix. And let's see what this does. I actually will do this in the command window so we don't have to rerun the whole program. Plot simple matrix. Okay, so that kind of did what we want, except not really. So you can see what happened here is it plotted the time value in X and Y, which is not what we want at all. We're going to do of so this is plotting columns 2 and 3 of all rows. Oh, I missed a parenthesis. There we go. Okay, and now we're starting to zero in on some semi-useful data. So right here we're looking at the time of engine start, and this is that decreasing curve where when you start your engine, your PCM, which you can see with the little jagged edges actually, we can zoom in here. So you can see that the PCM is setting different values. The PCM is here in blue, is setting different values for the engine to stay at. And then the engine, as measured, is following that curve. Now your engine does this at start, I believe just to get oil flowing. I'm not a mechanic, I'm just a hobbyist. So this is pretty interesting though. Now we can see, where is our PCM requesting that things be and where are things actually at. So you can see these spikes here that I guess correlate to pressing on the accelerator. And if we added back in that accelerator pedal state data, we could probably see that correlation. So yeah, we can see we get some pretty good spikes here. upwards of 2,000 RPM. I just took this for a short drive down to the local Walmart and back. But you can see when we're off the accelerator, and I assume this is at a stoplight. I'm not sure what's going on here. That could be an issue. But you can see that we're hovering pretty close. Our idle RPM is about exactly where the PCM would like it to be. And then we keep going down here. This spike is when I was sitting in the parking lot of Walmart, and I wanted to see if this spike would be recorded. And it turns out it was. So yay for that. And then you can see we're just idling here until I unplugged my diagnostic cable. But regardless, this is, in my opinion, very useful. This could allow you to get all kinds of information about, different things you can do with the data that you get from your car. Not just looking at, RPMs, but all sorts of things using the same methods that we did here, right? You can loop through this and look for just about anything you want. In this case, we look specifically for time, desired RPM, and engine RPM. Anyway, but you can see that we can loop through and look for just about any data that we want and make a graph and look at the way these things are interacting in just about any way we want. So hopefully you found this useful. Feel free to leave some questions in the comments. If I have time, I'll try to answer them. I do plan on making more videos about this, especially as I explore, how can we look at things like when the accelerator is on, the RPM is going up, is it going up at the proper rate? Things like that. This was just a very simple example of what's possible, and hopefully you can see that this was quite an interesting way to look at some of the data that your vehicle is giving you that you don't necessarily get when you're just driving around. So yeah, everything I used in this video was actually very, very inexpensive. It was a $17 cable that I will link below on Amazon. It's an ELM 327 clone. It works with FORScan. The license for FORScan, I paid for a 1-year license for $10 just because I didn't know if I would use it. Turns out I'm going to use it a lot. And to the perfectionists out there who note that I'm missing a parenthesis, there you go. It's fixed. So hopefully you enjoyed. Hopefully you got something from this. Hopefully it wasn't too boring. Thanks for watching.